Good day to all of you. Today we shall discuss on model question paper set 2 of the subject Digital Design and Computer Organization with subject code BCS 302. In that first we shall discuss on question number 6A. With relevant example, explain the following modes of addressing. First one direct, second one register, third one index, fourth one base with index and offset, fifth one auto increment. It carries 10 marks. So in this about 5 addressing modes, we have to explain with relevant example. Addressing mode means the way of specifying the address of the operand in the instruction. So solution, in that first one, direct addressing mode. Another name to this is absolute addressing mode. The operand is in the memory location. The address of this location is given explicitly in the instruction. For example, move LOC, R1. Move instruction copies the content of the source to destination. Source is a memory location called LOC. Destination is R1. So in destination, from where the operand is copied, from LOC memory location, that is directly specified in the instruction. This is called as direct addressing mode. Here LOC is the memory location from which operand or data is copied to register R1. Okay. Next, second one, register addressing mode. The operand is the content of processor register. The name of the register is given in the instruction. Example, move R1, R2. So here move instruction copies the content of source to destination, that is R1 register is the source, R2 is the destination. So to R2, from where does the operand does come? That is from R1 register. So the address of operand is R1 register itself, which is mentioned in the instruction. That is called as register addressing mode. Here this copies operand which is in register R1 to R2 register. Next, third one, index register addressing mode. Example, move 10 in bracket R1, R2. So bracket indicates this is address. So R1 stores address of some memory location. Say if it is 1000. To that this 10 is added. So this is index. So it becomes 1010. Hence from 1010 memory location, the content of that is copied to R2. This kind of specifying the address of operand in memory, that is called as index addressing mode. Here R1 holds the address of memory location. Say if it is 1000, then 10 R1 does 10 plus R1, that is equal to 10 plus 1000, that is equal to 1010. Hence the operand which is in 1010 memory location, it is copied to R2. Okay. Next, fourth one, base with index and offset. Example, move 10 in bracket R1, R2 bracket complete, R3. In this, address of the operand is 10 plus this R1 content plus this R2 content. Means both are having some addresses. They are added with 10. Okay, that generates the address of operand. So in this address, if R1 equal to 1000, R2 equal to 2000. If R1 is 1000, R2 is 2000. 1000 plus 2000, 3000 plus 10. So 3010 will be the address of operand. So from 3010 memory location, the operand which is there in that is copied to register R3 here. So that is what is base with index and offset. Next, fifth one, auto increment. Example, move in bracket R1 bracket complete plus, R2. So this plus indicates here auto increment. So R1 here in bracket, that is the address of memory location. If it is 1000, from 1000 memory location, the content is copied to R2, then that 1000 is made 1004. Means it points to next word address. So that is after copying, auto incrementing the content of this. That is memory location address is automatically incremented so that it can point to next word. Okay. If R1 register is having 1000, from memory location 1000, the operand is copied to R2 and R1 is incremented to next word address. So this is what is question number 6, a explanation of 5 different addressing modes carrying 10 marks. So we have to explain this with the relevant examples, and that was the solution. Okay. So next question number 6b. A program with 7000 machine instructions needs an average of 3 basic steps to execute one instruction. Find the performance of computer having a clock speed of 700 kilohertz. This carries 5 marks. So here find the performance means the computing time we have to find. Okay. So solution is here performance of computer means the time it takes to execute the program. That is P equal to N into S upon R, where N is number of machine instructions, S is average number of basic steps needed to execute one instruction, R is clock rate in hertz. Hence, substituting the given values, P equal to N into S upon R equal to N is 7000 machine instructions into average number of basic steps, that is S is equal to 3 upon clock rate is 700 kilohertz. So 700 into 10 raised to 3. So now what happens, this 2 gets cancelled, 7 ones are 7 tens are 10 threes are 30 here, this as it is. So this when it goes to numerator, 30 into 10 raised to minus 3, this can be called as 30 milliseconds, or when we literally divide by 30 by 1000, 0.03 seconds. Hence the performance of the computer that it takes 0.03 seconds or 30 milliseconds to execute the given program, and that is what is the solution. Okay. So 6b is over. So next question number 6c. What are the condition code flags? Mention the significance of flags N, Z, V and C. 5 marks. So here condition code flags means they are the bits in the status register of the processor. They indicate the status after computation. Okay. So N means negative, Z means 0, V means overflow and C means carry. Solution. Processor has a special register called the condition code register or status register. Whenever processor performs an operation, depending on the outcome of the operation performed, the bits in the condition code register are set to 1 or cleared to 0. These bits in condition code register are called as condition code flags. So bits in the status register, they are called as condition code flags. They will be set or reset depending on the outcome of computation, right? So with this, the processor keeps the track of information about the results of various operations for use by subsequent conditional branch instructions. So whenever a program is executed sequentially, one after the other, instructions will be executed. But when an instruction is executed, depending on the outcome, if you want to shift the control to some other block, then condition code flags are used. That is what is branching instruction, shifting the control to some predefined block depending on some condition after execution of an operation. Significance of flags N, Z, V and C. These are the commonly used flags. N, negative, set to 1 if the result is negative, otherwise clear to 0. Z, 0, set to 1 if result is 0, otherwise clear to 0. V, overflow, set to 1 if arithmetic overflow occurs, otherwise clear to 0. C, carry, set to 1 if the carry out results from the operation, otherwise clear to 0. If result of a computation is negative, N is 1. If it is 0, Z is 1. If there is overflow, V is 1. If carry generated, C is 1. Otherwise, they will be 0. Example, branch greater than 0 is a branch instruction that tests both N, negative flag, and 0, Z flag. If both are 0, it gets executed. Greater than 0 means it will not be less than 0 or equal to 0. Less than 0 means a negative, 0 means Z flag. If both are not set means definitely it will be greater than 0, and this branch instruction works. This is one example which utilizes condition code flags, negative flag and zero flag. Okay. So that completes the discussion of question number 6 ABC for a total of 20 marks. I hope you understood this. Thank you.